Welcome to Easy Math TV. We're going to do a correlation of two variables, which is part of simple linear regression in a package called StatCrunch. StatCrunch is a tool that is owned by Pearson. Anybody can purchase a license for it. You don't have to be using a Pearson textbook or a Pearson product. The license for StatCrunch, I don't know, is maybe somewhere around $15. I'm not sure, but it's a pretty good tool, and we're going to use it today to determine if two variables are correlated, and then and does that suggest that linear regression is warranted between those two variables. So the first thing we're going to do is load the data. So under data sets, when you want to search for data sets, you can search by keyword or tag. And if you type the word possums in the search bar, you will see possums in Australia and New Guinea, which I've uploaded. So basically go ahead and load that data into StatCrunch. We see several different variables. The variables are across the top, and each row number represents one possum. So in row 9 here, we have a possum at site number 1, whatever site number 1 is. VIC means that's the province from Australia that this possum was from. The sex is female. It was age 9 at the time of death. And then these are measurements in centimeters of the head length, the skull width, the total length, and the tail length. So what we want to do is we want to determine if all we know is the skull, so maybe all we know is the head, can we use the head length to predict the overall length, the total length of that possum? Maybe we're missing a part of the body or something, and we want to know if we can, if there's a correlation between head length and total length. So those are the only two variables that we're going to be interested in today. So what we want to do is we want to go under stat and then regression and simple linear regression, because there's only two variables. The x variable is going to be the head length. We want to know if the head length is going to be the predictor variable, and then the response variable is going to be total length. So can we tell something about the size of the overall possum by just its head? Okay. We don't need to do any group by things. Under the hypothesis testing, sure, why not? Let's do a hypothesis test on the slope. So we're not going to be very interested in whether the intercept is 0 or not. The y-intercept is likely going to be 0 in this case, because the head lengths can go all the way down to 0. If there's a head length of 0, the overall length is obviously going to be 0 for the possum. So we're going to be more interested in whether the slope is 0 or not. And when the slope is 0, that's when you have an indication that there is no correlation between these two variables. When the slope is not equal to 0, then we have an indication that there is a correlation between the two variables, either positive or negative, depending on what the slope is. So the confidence level is going to be 0.95, so that is fine. We don't need to transform either the x or the y variable in this situation. The graphs that we're going to be looking at are several. So pay attention to this, because we need to see the fitted line plot. And then since I'm using a Mac, I'm going to be pressing on the control key. But if you're on a PC, you will want to press on the command key. Other way around. On the Mac, I'm going to be pressing the command key. On a PC, you're going to want to hit the control key to hit a few of these different plots here. So we want the fitted line plot, and then I want you to scroll down here and select the histogram of the residuals, the QQ plot of the residuals, and then we want to see the predicted values versus the residuals. So those are the plots that we're going to be looking at. We also want to save, we're going to create a new column for both the residuals and the predicted values. So we want a new column for residuals and predicted values, okay? And I believe that is going to be good enough for us. So there's different optional characteristics that you can give to your graphs, but let's just leave it as it is. And we're going to hit compute. So let me explain to you what it is you're seeing here. The first thing is the hypothesis test for both the intercept and the slope. So since our alpha is 0.05, we are looking for p-values that are smaller than 0.05. And as you can see, the p-value for the slope is certainly much, much smaller than 0.05, which indicates that there is, that the value of the slope is not in fact 0. So like that is a very strong indication that there is a trend. There's a trend in either the positive direction or the negative direction between our data points. You know what I mean? So like that right there is treated in some instances as a hypothesis test for the linear equation. You can actually see up here is your R value. Our R value for the correlation is 0.69, which is also it's kind of on the strong side. And then here's your prediction equation. Your prediction equation says that the total length is going to equal 9.888, or basically 9.89, plus 0.83 times the head length. So the slope and the y-intercept of your prediction equation is right there. Okay. So next, we can actually see our scatter plot. This is the scatter plot of head lengths versus total lengths. And there is a trend upward of the data values. So that's a pretty strong correlation right there. The histogram of the residuals is going to show us whether or not the residuals themselves are truly random, and that the mean of them needs to be 0, and the correlation between the residuals and the predicted values also needs to be close to 0, which we're going to see in a moment. But so the histogram is pretty good looking. We don't have like a long tail going in either direction. So the histogram of the residuals does show that our residuals are kind of normally distributed. And there's our QQ plot of the residuals too, that shows that they're fairly close to that straight line, which means that the residuals themselves are in fact normally distributed. So like you need those things to be true. We need the QQ plot of the residuals to be following a straight line. We need the histogram of the residuals to be roughly normally distributed. We need the scatter plot to show a trend either upward or downward. And we need that p-value of the slope to be less than our alpha, which is 0.05. So the p-value of the slope needs to be less than 0.05. If we've got all of those things, then you have a pretty strong case for your linear regression equation. The only other thing that I would suggest that we do is now do our, we should do a plot of the residuals versus the predicted values. So let's go back to stat and do a regression, simple linear regression of residuals versus predicted values. And hypothesis test. So this time we're just going to do our fitted line plot. We're going to see what the R value is for the correlation between those two values and what the fitted line would be. So let's do compute. So the R value, you will notice, is there's this little, it's not 6.69, it's 6.69 times 10 to the negative 14th, which means that it's 0.0000 with 14 zeros, 669, extremely close to zero, okay? And when you see an E, a little E and a negative 14, that means that there are that the decimal has 14 zeros in it before you get to the non-zero 669. Okay, so it's like 0.000, 14 zeros all the way out before you get to anything that's not zero. So that little e, that exponential notation there, e negative 14, means that we have a decimal that is extremely close to zero. The p-value for slope not equal to zero is 1. So that tells us, wait a minute, there just is absolutely no correlation at all. There's your residual plot, by the way. The residual plot versus the fitted values needs to look extremely just random. I mean, this is as random as it gets. The fitted line is like literally a flat line. So when the fitted line is a flat line with no slope and the residuals are all over the place like this, there's no pattern in the residuals versus the predicted values. And our R value is a number close to zero. So you need that to happen as well. The last thing that we're going to do is we're just going to do a summary of our residuals. So under stat, let's go to calculator and, stat, summary statistics. And we're just going to look at the residual column. And I want to know the mean of this thing. So I don't need to unselect any of these. This is fine. So we just want to know, we want a summary of our residuals. So compute that. And we're looking for a mean that's as close to zero as possible. And we have that E negative 14 again there. So seeing that exponential notation means that that number is a number extremely close to zero. It's 0.00000 with 14 zeros, 20359. So yes, the mean of our residuals is balanced with a mean of zero. So that means that you've got as many residuals on the positive side as you have residuals on the negative side. And you know, it also is an indication that it might in fact be randomly be normally distributed. We can actually do a goodness of fit, a normality test on the residuals themselves, and look at the QQ plot and the histogram as well. So we can do a test for normality. I'm going to compute that. And in this case, the p-value is 0.5447. There's our plot. And there's the histogram. So the p-value being 0.5447 means that there is not, we don't have strong enough evidence to reject the null hypothesis. We do not want to reject the null hypothesis that the distribution is not is normal. We're not rejecting it, but essentially you can see the QQ plot here, and you can see the histogram here as well. So the test for normality, it doesn't fail it. But all of those things need to be performed if we want to be able to justify being able to use just the head length of a possum to predict what its total length is. And you saw what the prediction equation was when we did the simple linear regression. So that concludes my video on how to use StatCrunch to determine if two variables are in fact correlated and what that correlation would be. Is there strong enough evidence to support that it's linear, and what would the linear model be? So like, subscribe, comment down below, and I hope you're enjoying these videos.